This video tutorial is the solution to problem 3.32 in Munson's book. The problem statement is about finding the velocity of air passing under the door through the crack, and the information that is given is the pressure difference between the inside of the room and the outside. This is a typical requirement in labs containing contaminants, so that in case of a leak, the air from the lab does not flow into the corridor and cause dangerous condition. Rather, it flows towards the exhaust and gets thrown away or thrown out. So in this case, the pressure difference between the outside and inside is given to be 0.1 inches of the water. And I think this is the most tricky part. You cannot use 0.1 inches of water when the flow is happening for air. So you have to convert this into actual pressure and then find out what's the head, or use that pressure as is in solving the problem. So this problem will be solved using Bernoulli equation. First of all, we'll look at this drawing. The pressure in the corridor is higher than the room pressure, and we know that P1 minus P2 over gamma water is given. This is given to be 0.1 inches, and of course we have to divide it by 12 to convert it into feet. So this is given, and what we need to find out is the velocity with which fluid is moving out of this under the crack. So we will follow a streamline. We will consider 2 points, and we will follow a streamline along this path. At section 1 we have P1, V1 and Z1, and at section 2 we have P2, V2 and Z2. First of all, we write the Bernoulli equation, and in this equation we know some things. We know that in the corridor the ambient air is, we can assume it to be at rest, so this term goes to 0. And since Z1 and Z2 are equal because of the flat surface, they will also cancel. So the resulting equation can be written in terms of V2 that we are trying to find out, and this becomes the square root of a function of the pressure difference. Now we can go back to this equation and find that pressure difference, which would be P1 minus P2 equals 62.4 pounds per cubic feet, which is the gamma of water, times 0.1 over 12, and this gives us 0.52 pounds per square feet, which is the pressure difference between the corridor and the room. And we can use this number in this equation, which is 2g times 0.52 divided by gamma air can be written as rho of air times g, where g can be cancelled, further simplified. And we know that rho of air, you can check this from the back cover or appendix of your book, that is 0.00238 slugs per cubic feet. And by plugging this number into the equation, you will find that V2, which is the velocity of the air through the crack, is given by 20.9 feet per second.